So today we're talking about combining like terms. I said not to worry about those little words over here, but I want to talk about what those three things mean. So first thing is the word combining, okay? When we combine two things, what do we usually think about in terms of math? Combining two things. Addition, right? Putting two things together. Now, the question is, if I have a positive number and a negative number, when I combine, what am I actually doing? A positive number and a negative number. I'm subtracting, right? Yeah. So combining could look like addition or it could look like subtraction. Okay? When we think of the word like, we think of the same or similar. Now, terms is something we talked about yesterday with our vocabulary lesson. And terms are parts of an expression. Okay? A term could be a variable. It could be a number. It could be a number and a variable together. So terms could be numbers, they could be variables, or they could be a combination. So today we're going to talk about like terms. And when we see like terms, we know that they can be combined. We're going to talk about the types of terms that cannot be combined. And then we're going to talk about if we have like terms, what does it look like to combine them? Okay? So I want you to open up your like terms flap. Like terms are terms that can be combined. So when we see them, we're going to put them together. We're going to add them or subtract them. All right, in order to have a like term, the terms have to have two things the same. They have to have the same variable or no variable at all. And they have to have the same exponent or no exponent at all. So like terms have to have two things that match: the variable and the exponent. Or they may have neither. And we call those constants from yesterday. So like terms have the same variable and the same exponent, or they have neither. If you look below, we have some examples of some like terms that we could combine together. 6 and 8 are like terms. We called those constants yesterday because they have no variable and no exponent. Do you know how to add 6 and 8? Yeah. You know how to do that, so you can. 2a and 4a are like terms because they both have a variable, a. They have no exponent, so we don't have to worry about that matching, but they have the same variable. (3x squared) and 5x squared are like terms because they both have x's and they both have an exponent of 2. And xy and 2xy are like terms because they both have x's and they both have y's. Everything has to match with the exception of one thing. What thing do you notice doesn't match in any of those pairs? The variables match, the exponents match. What doesn't match? Shay? The numbers, right? We call them coefficients. So the numbers that are next to the variables aren't what tell us whether or not we can combine them. They're going to be important because they're going to tell us how to add or subtract the terms. But they do not affect whether or not the terms can be combined. The coefficients, those numbers, don't have to match, but your variables and your exponents do. Does that make sense? Okay. So let's talk now about unlike terms. All right. Unlike terms we cannot put together. So if we see them in a problem, we are going to leave them as they are. Okay? We're going to leave them alone. Unlike terms have different variables or exponents, or both could be different, one could be different, but something doesn't match other than the number. So terms that have different variables or different exponents. And I know it's kind of hard to read there, so I'm going to read the examples because I wrote them and then we crossed them out because they're not like terms. 2a and 4b are not like terms. This one has an A, this one has a B. One of the examples I always like to use is if we go to McDonald's and we want to order 2 Big Macs and 4 orders of French fries, okay, we can't go up to the cashier and say, I want 6 Big Mac fries. They're going to be like, what in the world are you talking about, right? But we can go up and say, I want 2 Big Macs and 4 orders of French fries. We can't combine those things because they're not the same. Okay, and when we talk about distributive property next week, we talk a lot more about combining food items, and then everybody gets really hungry before lunch. Okay, so 2a, 4b, variables don't match, so we can't put them together. This example right here, we have 6 with no variable and 4 with an x. Since this one has no variable and this one has an x, they are not like terms, so we cannot combine them. Down here, 3y squared and 4y. They both have y's, but the first one has no exponent, the first one has an exponent, the second one does not. So that part doesn't match. Our last example, 2ab and b. Here we have an A, here we do not. So notice everything has to match but those coefficients, but those numbers out in front. One little thing is off, like we're missing an A or missing a squared here. It makes them not be able to be combined. This goes in the unlike terms. Any questions, or do I need to pause for a second so you guys can catch up on this?
Yes, please.
Okay. All right. It's okay. You can come later. So now we're going to do some practice. I want thumbs up or thumbs down, and I'm going to go through each one. 3x and 2x. Thumbs up if they're like terms, thumbs down if they're unlike. 3x and 2x. 3x and 2x. Just this first pair right here. Like terms or unlike. Thumbs up for like, thumbs down for unlike. What's different about 3x and 2x?
I thought you were like.
Do the variables match?
No, because it's 3 and 2.
Do the variables match?
Yes.
Yes. We're looking at variables and exponents only. So those are like. We'll circle them. What about 8a and 8b? Like or unlike? Why are they unlike?
Because there's a y for the 4, and then there's
Go ahead.
A.
Yeah, one has an A, one has a B. I was waiting for somebody to raise their hand and be called on.
I was like this.
I know. 4y and 3y squared, like or unlike? Why are they unlike?
Because they're squared.
This one has an exponent, that one does not. 8 and 10, like or unlike? Why are they like?
There's none.
There's no variable or exponent.
I forgot the word.
Negative 6x and 3x, like or unlike?
They're unlike because one's negative
Ooh.
No.
But the only thing we look at are exponents and variables, so they are like. I threw in a tricky one. What about 8xy and 5x? Why are they unlike?
I know.
They are unlike because one has a Y. The 8 has a Y.
I know that.
Okay, very good. All right.